GreenSense show is sponsored by CEA Technology, providing a sustainable modular indoor growing system. Visit CEATechn.com to learn more. I'm Robert Colangelo, and this is GreenSense, where we bring you eco-innovations that are changing your world. What if the glass in a greenhouse was also a solar panel, allowing the semi-transparent solar panel to absorb energy from sunlight without blocking the light that the plants need to convert into chemical energy to grow? My guest this week is an engineer with UCLA that asked the what if question, but also built a bench scale greenhouse to test this hypothesis. Here to tell us more is Yang, lead scientist at the UCLA Samueli School of Engineering. Yang, welcome to GreenSense.
Thank you, Robert. Good to be here.
Well, how did you come up with this wonderful idea?
We had this transparent or semi-transparent solar cell since 2014. That was but at the time when we built the transparent solar cell based on organic compounds, we never thought to combine with agriculture. So combined with agriculture was just recent couple of years that when we see what kind of application that we generate from these wonderful ideas. So one application that the student came out is to combine the transparent organic solar cell with the greenhouse, the agricultural greenhouse. So the advantage is that we can design our molecule to pick up particular light that the plants don't need it for their growth. And then we can let the important light like UV and the red color light that the plant use the most.
Let's get into that in a second. Our company builds vertical farms and greenhouses. Mm-hmm. And if you could scale this idea, it can have a fantastic economic impact on indoor growing. As you know, greenhouses require electricity to run motors that automatically open vents, raise shade screens, operate pumps to convey nutrients to the plants, and then they power supplemental lighting to provide year-round crop production. Now, other companies have had this idea and are producing PV panels for greenhouse application, such as Onyx, Mitrees, and Solar Culture. What makes your experiment unique and your idea different?
First, I did not know we have a competitor exist. So
I'm not sure if they're a competitor, but they're making they're making PV panels for greenhouses that produce electricity and let the light in.
Well, produce electricity is not difficult. You can just have a silicon solar panel, but with not fully covered with say 50% covered by solar panel, the other 50% of the sun pass, but it's non-selective. Our idea is, as your question, what make our idea stand out is that we actually, as I mentioned earlier, we are able to design our molecule such that it picks up special portion of wavelengths the plants doesn't need to use it. And more important is that that when we provide those kind of semi-transparent organic solar cell, we found that the plant actually grow better, because we filter out those harmful lights or cut down the intensity, and also save the irrigation, save water as well.
So that's pretty unique that you're able to split the light waves so that you can produce electricity and the plants can also use it for photosynthesis. So you built a small greenhouse to experiment with. Tell us about that test greenhouse. So what was the dimensions? What was it made out of? Did it use a bench or hanging gutter hydroponic system, or was there other cultivation methods you used in there?
Actually, that would be best answered by my student, but he's working on the important experiment now. So let me answer for him on his behalf. Dr. Zhao, Yeping Zhao, is the first author of the paper. So we built a greenhouse about the size of about 1 foot or 12 inch or 16 inch by 12 inch. In size, and then the height is about 12 inches. So we cover the greenhouse with the organic solar cell on top of that, and then we grow different kind of seeds inside. And we compare two greenhouses, no coverage at all, just transparent glass. Compared to our and the semi-transparent solar cell, we found our plants actually grow better And then later we talked to someone who is expertise in the agriculture. He said, it is actually true. He said the best growing condition are the plants under the shades, not really under the direct sunlight, particularly in California. So that offers some explanation to our observations.
Well, a big challenge for any greenhouse is controlling the indoor climate and controlling pests and providing a consistent nutrient solution. How did you achieve this in such a small test area?
Oh, we don't control at all. We just have an enclosure environment. And so that's a very rude first degree of study. And of course, if you want to go any further, we really need to work with real farmers and real vertical growth system, like you mentioned earlier. So we are open-minded to see whether we can collaborate with others. So that's why we are a public university. We like to see our research can benefit our society, also our industry. Yeah.
Well, it's easy to, what we have found is that it's very easy to grow indoors in a very small area, but there's big challenges once you start to scale up a facility so that it's available for commercial production. What do you see as the challenges to scaling up your technology?
Scale up is always a challenge, no matter what. Okay, you cook one pizza is one thing. You cook 10,000 pizzas is different. Yes, in our case, because if we build solar panels with large dimension, the efficiency tend to drop because just like electricity, you send electricity from nuclear power plant to a household, you lost about 30% of electricity because the copper wire are not perfect conductor. So similar argument that apply to solar cell, organic solar cell in this case, is that when you build solar panels a little bit bigger, the efficiency tend to drop. That's because the metal wires and other things, we have to pay a tax on that. So that's the one issue. So the challenge become, how can we make the solar panels a large size, the size we want, but still maintain the same efficiency? That still requires a little bit of homework. So that's one thing. The other is the molecule that we make are not cheap. That requires a lot of money. I mean, to make a large production requires some severe investment. So because we're only in the university, we are not in the position to make a large volume of chemicals. So we hope perhaps your radio program can help us to attract people who are willing to work with us.
Yes, I think the idea is fascinating, and I think it has real potential, as I mentioned in the intro. You also did several experiments. Tell us about what cultivars you grew, and you told us the plant quality was good. How were you able to scientifically prove that?
That really need my student to answer that. You can understand I'm not the person who really carry out the experiment by myself. I think we grow some of the seeds, and then the way we correct that. Actually, one of the referee asked us to do some DNA sequencing, which I don't even know how to do that. But is we really measure the dimension, what is the height grow. So the height that we have and the size of the plant, and both under the sun and under the shade, actually under the shade to grow better size. And so I don't know whether it's scientifically enough, but at least it offers some reference point.
Yeah, traditionally the way they test plants is either through biomass, dry or wet, and by taste. And of course, by color and by look, if they're edible vegetables. So it sounds like maybe you were a little earlier, or that's not your expertise, but I'd be very interested to see how you quantified that.
Oh, well, that would be great if we can have someone, some agriculture department or some farmers, people like your audience.
Yes, and we've worked with the University of California, Davis. They do tremendous work in horticulture. It's something you might want to look at collaborating with. They've got different scales for testing and measuring, plant efficacy. Well, the produce business is very competitive, and to be successful, you have to control your capital expenses and your operating expenses. Have you done any economic modeling to understand how this will impact the design, build, and operating cost of a greenhouse using these PV panels?
Not yet. I'm waiting for someone to help us.
Yes. Well, that's okay. You got to start somewhere.
It is
Scale,
fascinating, and usually typical my way is that if student from my group willing to take this one step further to commercialize, I will give them this one as a souvenir for the graduation. They can move on to their career with something that they like to start a company or challenge themselves to move to the next milestone.
Have you calculated how much energy or electricity you could generate, and can the greenhouse be self-sufficient and off the grid by producing enough electricity to run all those motors and things I talked about earlier?
It depends on the size of the greenhouse. If the roof area is big enough, that I think because our efficiency is pretty good. It's about 14-15% small dimension, but once you make it bigger, let's say you drop to 10% efficiency. A typical household solar panel on the roof is about 20%, the best one. So we are about half of that. So, but we can wrap around the greenhouse, not just the roof. We can also wrap around the wall as well. So all things considered, I think we probably can produce quite significant amount of electricity. Of course, we're talking about you need the storage, you need the battery to charge those electricity during the raining day or during the night as well. But by all means, I don't have a number, but if you want me to sit down to calculate it, how many watts can generate, I think, and also let me know how much watts a pump or light fixture takes, then we can probably come out something, if not 100%, at least partially.
Yeah, I would be interested to know your square feet of PV panel space versus the amount of electricity it produces, so that you had a ratio of how many panels you'd need per, square foot of footprint of a greenhouse. But that's something you may want to take a look at. Yeah.
We will cover them all. And more importantly is when we published the paper in 2014, as I mentioned to you, we only have 4% efficiency. Now we are 14.
It's pretty good.
So 3 times more, 3 times plus improvement.
Yes. Yeah, but as we said, it's easy to do on a small scale. Let's see what happens when you scale up. Most glass houses are in cold climates because the cold glass provides better insulative value. You conducted your experiment in California where you have a lot of sun, and most greenhouses in California are constructed a very simple plastic or shade screen. What, in your thoughts, how would your results vary if this experiment was done in the Midwest where it's cold and not as sunny?
Actually, that's a very good question. For example, we can build our solar cell using based on the insulating form. So the solar cell is thermal insulating, not just optically. And then our solar cell is organic, and organic solar cell has a better light absorption compared to silicon. So our efficiency is pretty good in the dim light condition. So the reason is very simple, is a simple physics. That is, our index reflection are smaller, so the light is easier to get in, unlike silicon has index. So that's why you see silicon solar panel are very reflective. You can see the reflect light. So that's the advantage of our solar cells. Okay, so in Midwest, we need to, I'm a scientist, I let the experimental data to tell, but in principle, I think we might be able to do a pretty good job based on what I just mentioned to you.
So as I mentioned, many greenhouses are made of many different materials than glass. Mainly it's in the cold climates you find the glass greenhouses. Is there a way to put these in the plastic greenhouses?
Of course, absolutely. In principle, we are building things on a flexible substrate, so they can laminate on the surface you're interested. On a plastic, you think about the good old days, we have these transparencies. We usually use a transparency to do presentation. We can build the organic greenhouse solar cell on those transparent plastic films.
Yeah, that would be excellent. It would make it, I think, more globally accessible. since you were doing experimentation, and when you experiment, there's always things that you didn't expect to find out. Did you have any unexpected findings while you were doing this experimentation?
Oh, the biggest surprise was we thought when we cut down the light that the plant will grow worse. It turns out to be, at least in California, Southern California, the plant actually better. And then one day I went to, I don't remember, this central California Valley. There was a lot of agricultural land. And during the off season, they actually cover the land with white collar plastics, not in the greenhouse, but those white collar plastics, they cover on the land. They can be our solar cell. And on the other hand, our solar cell doesn't need to be on the greenhouse. It could be as a coverage for the land.
Interesting.
Yeah.
Were you able to measure the amount of light coming into the plant, either using a PAR meter or direct light integral?
Oh, we can do that. All we need to do is just do a mathematical calculation, which we have probably done that. That is, assuming the light, you do the integral as you mentioned, then you do the measurement, and then you just do integral the whole wavelength. You should be able to do that.
But in your experiment, did you measure that?
Probably we did. I would be surprised we did not.
Okay.
But,
I would think so too.
Yeah.
So what's next in your entrepreneurial journey? You took the hardest step. That's the first one. You've done a bench scale test. Where are you going from here?
Okay, we want to increase the efficiency, and a lot of infrared light we still not utilize yet. So we are designing new molecule. It go into more infrared, harvest the infrared light, increase the efficiency, but it's transparent to the visible light, to eyes that you don't see it. Okay, so that's what we are doing right now. So quite exciting.
It really is. Anything else you'd like to share with our listeners in closing?
We are very excited about this opportunity of making that the greenhouse multifunctional. And my slogan is turn the greenhouse into a powerhouse eventually, hopefully. And hopefully all the greenhouse can be off-grid as you described. And so that's how we think this technology, which original from this country, hopefully we can turn that into an industry in the made in America in this country.
Well, Yang, I'd like to maybe reach out to you in a year and see what kind of progress you've made. But thank you for joining us on GreenSense. It was a pleasure having you on the show, and I hope you're able to commercialize your technology because it could revolutionize the greenhouse industry.
Let's do it together. Let's do it together. Myself alone cannot do it. Thank you so much, Robert, and wish you a happy day. Okay.
That's Yang, lead scientist at the UCLA Samueli School of Engineering, sharing the recent agrovoltaic study with using PV to power both plants and motors in a greenhouse. I'm Robert Colangelo. Thank you for listening to GreenSense, and check out the GreenSense Minute every Thursday and Saturday on 105.9 FM, WBBM Chicago. And visit the greensenseshow.com website to learn more about sponsorship.